Hello students, in previous class we had looked into the introduction of the decision tree and its important features and you had seen one example and all, right? So today we can look into some of the definitions of the uh, tree construction principle, Gilton cut and the generic algorithm, which is the important section in a decision tree. Okay, so here we can see that splitting attribute. So splitting attribute actually here means you can see some training data set, right? So it's a data set where you have the attributes like age, income, student, credit rating, bias computer and all. So in this diagram it is a decision tree. This decision tree you had seen in previous class, that is whether the which age group are buying the computers, right, in AI electronics. So here you can see the attributes are splitting, right? The attributes are splitting into the different forms. We can split this into the income, student and all, right? So this is like splitting, how we can split the particular attributes. Okay, so splitting attributes, with every node of the decision tree there is an associated attribute whose values are determined the partitioning of the data set when the node is expanded. So we can expand the node, we can use the splitting attribute. Okay, ನಮಗೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ನೋಟ್ಸನ್ನು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡೋಕ್ಕೆ ನಾವು ಆಟ್ರಿಬ್ಯೂಟನ್ನು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಕ್ರೈಟೀರಿಯಾ. The qualifying condition on the splitting attribute for the data set splitting at a node is called the splitting criterion at that node. For a numerical attribute, the criterion can be equation or an inequality. For a categorical attribute, it is a membership condition on a subset of values. So splitting criteria means, so here we can split the values also. Okay, so here you can see the value is age. So here it is a categorical attribute. Okay, so here age is youth, middle aged and senior. So when you consider this numerical value, the age must be, right, the age must be less than equals 30, middle age will be 31 to 40, then greater than 40 will be the senior. So like numerical value will be represented here. Now here it is a categorical value. Okay, so it is known as a splitting criteria. So as you know, yesterday's class I have clearly mentioned what is numerical attribute and categorical attribute. Numerical attribute includes the values and the categorical includes the values, that is text. Okay, so this is about the splitting attribute and splitting criteria. Students, please don't draw this in your notes. Okay, so here is another diagram I had put, that is the attribute age with the height gain information. Therefore, this attribute is considered the splitting attribute. So here you can see the age is divided into the different, by considering one particular attribute, the splitting take place in three forms and calculation also. Okay, so this is how the splitting and all takes place. So gain information is one formula is there. Okay, so the definition we can see in next classes and all. So this diagram also you don't draw in your notes, just it's an example. You can see how the attributes are splitted. Okay, so in decision tree we have three important phases. Okay, that is construction phase, pruning phase and processing the prune tree. Construction phase. The initial decision tree is constructed in this phase based on entire training data set. So in construction phase, here we will be considering the entire training data set. By considering the entire training data set, the calculation will be take place, the partitions will be take place and splitting takes place. Okay, it is about the construction phase. Okay, so here it requires the recursively partitioning the training set into two or more subpartitions using the splitting criteria until a stopping criterion is met. Next we have pruning phase. The tree constructed in the previous phase may not result in the best possible set of rules due to the Overfitting. The pruning phase removes some of the lower branches and nodes to improve its performance. So here in pruning phase, it removes the unwanted data. Overfitting here means the data set which includes the noisy data. Okay, so that all will be removed. So to remove those and all, we have the mean, median, mode calculation and all. Okay, so it's a overfitting. To remove those such phases or values and all, we use the pruning phase. Next, we have the processing prune tree to improve the understandability. Okay, so when we have the number of splitting and all, to minimize those, we will be using the pruning phase. So these are the three important phases in the decision tree. Okay. Next, we have got the generic algorithm. So one of the important algorithm. Okay, they might ask in exam, explain the generic algorithm. Okay, so here in this generic algorithm, it says what is training data set, class, and why we are splitting the attribute. Then we need to predict the data, right? Accuracy, to find the accuracy of the data set. Then here we have three stages, that is homogeneous, not homogeneous, and a travel section of a while considering the training data set. Okay, so first we can look this. So here most of the existing algorithms of the construction phase use the Hunt's method as the basic principle in this phase. So when we are using the algorithms in construction phase, so here as already we discussed, that is in construction phase we will be considering the entire training data set. Okay, so there the Hunt's method will be used. Okay, so here let the training data set be T. So training data is set is T with class label C1, C2 to Ck. So till now we had seen the class labels of C1 and C2. So we can have the more number of class labels also. Okay, that is represented in form of C. That is a testing data set. Okay, so testing data set is we are known. Okay. Next we have the point, that is the tree is built by repeatedly partitioning the training data using some criterion like the goodness of the split. So as you know, by considering the splitting, after considering the splitting only we can find out the value. So we used to split the attributes and find out the result. To find out the result and all, there is a formula. Okay, that is not given in detail for in your syllabus. So when you study the masters, you will be knowing how the calculation takes place when you are splitting the data and all. Okay, so here the process is continued till the end, at the end of the record in a partition belonging to the same class, to which the partition belongs to the class labels. So this is about the generic algorithm, and we have three stages, that is T is homogeneous. T contains cases all the belonging to single class Cj. The decision tree for T is leaf identified class Cj. T is homogeneous means we are identified by considering the splitting attribute and all, we find out the result, that is this particular data set belongs to this class label, right? It's a Cj only. Next we have another situation, that is T is not homogeneous means where it may has both the result also, both the nearest result. So it is a not homogeneous, we didn't got the perfect output, targeted output. Okay, it is a not homogeneous. T contains cases that belongs to the mixture of classes. A test is chosen based on a single attribute that has one or more mutual exclusive outcomes, that is O1, O2 to O1. So when we are considering the single attribute, we have the many number of results. So it's a mutual exclusive outcomes. Okay, T is partitioned into the subset, that is T1, T2, T3, T4, where T contains all those cases in I that have the outcome 0 of the chosen test. The decision tree for T consists of a decision node identifying the test and one branch for each possible outcome. So when we consider the training data set, we may split the data set into number of elements, and we will try to find out only the one result, the chosen test, that is either yes, either no. Okay, so the outcome 0 is a no. Okay, the decision tree for T consists of a decision node identifying the test and one branch for each possible outcomes. The same tree building method is applied recursively to each subset of training cases. Most often n is chosen to be 2, and hence the algorithm generates a binary decision tree. So binary decision tree means where you have the result like yes or no, the two form of results. Okay, so here T is not a homogeneous. The another one is T is tribal. T contains a no cases. The decision tree T is a leaf, but the class to be associated with the leaf must be determined from information other than T. The generic algorithm of decision tree construction outlines the common principles of all algorithms. That is, nevertheless, the following aspects should be taken into account while studying any specific algorithm. In one sense, the following are the three major difficulties which arise when one uses a decision tree in a real life situation. So most of the time, so you had seen the three situation, that is tribal. So in tribal it doesn't contains any cases, means information. So here leaf must be determined from the information other than T. Okay, so other than considering the training data set, it has considered the classes and all. Okay, so here in decision tree it is not a best algorithm in classification, means here it will look after only the binary relation, the binary class only it can be considered. When it has the many number of classes, we can't use the decision tree algorithm. It is very suitable only for the binary relation data sets. Okay, so this is about the generic algorithm. Okay, next we have some definition, that is Gilton cut means splitting one single attribute leads to a rectangular classification box that may not correspond to well with actual distribution of records in the decision space. We call this as Gilton cut phenomena. Means you had seen in this example, that is the data set has been divided into the rectangular form. It is splitted into the rectangle form. So this is known as a Gilton cut. Okay. So next, overfit definition, that is a decision tree T is said to be overfit the training data if there exists some other tree T which is simplification of T such that T has smaller error than T dash over the training set, but T has a smaller error than T over the entire distribution of instances. Means overfit, as you all know, overfit where it has a the data set may have the error values and all. So it's a overfit to overcome this. So here overfitting can lead to difficulties when there is noise in the training data or when the number of training example is too small. There are many disadvantages of an overfitted decision tree. That is, overfitted models are incorrect. Okay, overfitted decision tree requires more space and more computational resources. Then we have overfitted models requires the collection of unnecessary features. They are more difficult to comprehend. So in overfitting, as you know, it's a errors. We need to remove these errors and all. We can have the calculation like mean, median, and mode and all. Okay, so you need to study these definitions and all. Okay, Gilton cut, overfit definition, splitting attribute, and splitting criteria. So in next class we can study about gain information, gain ratio and all. So those are all definitions you need to understand. Okay, thank you.